Hello and warmest of Septandi greetings to you and yours. Last time we started off a new series of videos where I went back in time and took a look at my Moon Patrol clone that I started writing in assembly language and never finished. And in that part we took a look at what the files were that I was left with, and I tried to reconcile and figure out which are the old ones and which are the new ones. In this version, we're going to see how I managed to do sprite management. But I'm probably not legally allowed to use the word sprite or the word management, and you'll probably see what I mean once you see exactly what I did. Anyway, let's take a look. So I went through and I tried to compare all the different files, trying to get what seemed to be the latest version of each thing. I got a few different categories of file. I had a bunch of assembly files, whole bunch of basic files, and I remembered that in order to run the code, I would have this driver program in BASIC, which would load in various pieces and then set it going. This is what a lot of the driver files looked like. So it would do all the P mode stuff in BASIC. And then there's generally three categories of binary files that would load in. Assembled code, the machine language code, the artwork, the backdrop, and then that data thing. I always did this poke. I looked it up. Apparently I must have read somewhere this is what you do to make sure that the floppy drive motor is off. I mean, this does a whole bunch of things. I don't think any of those would have mattered to me, but just by setting it to 0, that turned off the motor. Because I think what might have happened was I maybe load-emmed all of this. The motor keeps on going until like a little timer tells it to stop. And once I started executing here, I think maybe that timer never told it to stop. I don't remember any of this stuff. So then it would let you look at the backdrop until you hit a key, and then finally it would run this code to start running at 3F100. Other driver files look quite similar, but slightly different. Like instead of running schla2, this used trial2. I guess it was all depending on what I was trying to test at the time. This one would let you choose between the first backdrop and the second backdrop. Then it would load that code and run it. This one didn't do data for whatever reason. Interesting. This one did, I think, a very targeted test of the scoring system. I think that's what numbers is. I haven't tried this one yet. This one I looked at. This does a very targeted testing of a p-point routine. So I did something in assembly that does the equivalent of what p-point does in BASIC, where you can ask what color a particular pixel on the screen is. So it looks like I would set a whole bunch of pixels, and then I would send that as a parameter to the routine to ask it, hey, what do you think the color of 1436 is? I would call the routine, and then I would look at what it returns. So I think this was just the way I tested. So I guess you could say I was doing unit testing. That's something, and I was doing that in BASIC. So that covers the driver files. I also had files that would do the artwork in BASIC. So for example, this I think drew one of the enemies. This drew, I think, what would have been the next enemy, but as I recall, I never actually got this one up and running. I just started on the artwork for it, I believe. And this is what started getting me into figuring out what this data thing is. So I mentioned many of the driver files load in this data file. So I'm switching to the assembly file, I think, which contains maybe the latest version of all the different pieces, or at least my attempt to do that. There are some equates at the top that start at 6,000. So this would be enemy 1-1 starts at 6,000. HLE DAT starts a little bit later, HLE rep starts a little bit later, car DAT starts a little bit later. So these are all like in the early 6000s. These don't even have any references, as you can see, but this one does. So it's referenced here, and it's grabbing bytes of enemy 1-1, And that's in a subroutine that controls the enemy. And so this is what's gotten me thinking, this must be sprite data. All of these bytes are the graphic data, the graphic bytes to draw the pieces that need to animate. So rethinking that, this must be the data for a hole inside the ground. This must be the data for what you get when you replace the hole, so that like as things scroll around, you don't see the hole every time. And this must be the graphic bytes for the car itself, which can jump and move a little bit to the left and the right. But where did these bytes come from? How did I get them into 6000? And that takes me back to that basic file. I think how this was used is I had a basic program that would draw something on the screen, and then this would peek at those bytes that I drew, and it would poke them into addresses starting at 6000 something. So for example, this one was dealing with stuff at 6142, which would relate to the car. It was very helpful when I found this handwritten comment on the printout, which went into a little bit more detail about the different pieces of the data that come from 6000. So this is where the enemy thing starts, and it had two different poses. So this was like a animated sprite, I guess you could say, that kind of flipped and flopped between two different snapshots. And so these were the ranges for those snapshots. This was the range for a hole in the ground, and this would be the replacement. If it weren't for this, I wouldn't have known what those things stood for. Here's the car, and then even beyond that is where that other enemy would be. I don't actually know if it's even in there or not, but that's where it would have been. And here's a longer basic file that put a bunch of stuff into that region of memory in the 6000. So this both would draw that first enemy, and then at the end, it had a loop to peek what was there inside the graphics memory and poke it into the 6000s. So I opened the data file in a hex editor, reasonable preamble of the format I was expecting. I talk about the preamble and postamble in this past video, and I put a link in the description if you want to follow up on that later. You always want it to start with 00. This looks like a reasonable length. And this is certainly the start address, 6000, so that made sense. And if I go to the bottom to look at the postamble, you want it to start at FF, then you expect a 00, and then finally the execution address, which I made it be 6000, but it doesn't matter because nothing gets executed. It was a little odd that I saw like text in here, because these are really supposed to be graphic bytes, but it's possible these were just like unused, and like whatever happened to be in memory is what filled them up. I don't know. What I need to do is to go through this and figure out how to decode it. So I know I have code that uses this to move the enemy around. I know I have code to use this to move the car around. But this whole stuff, I just don't know. So I need to do a little bit of math to figure out what the dimensions of this stuff is. I assume it's a rectangle for each one, probably of the same size. So I'm going to take 10A, subtract D2, and that gives me 56. So it's going to be the product of two numbers, maybe 7 times 8, 8 times 7. I'm going to guess it's probably as close to a square as you can get, maybe, because if I recall correctly, the hole wasn't super deep or super wide. So I'm going to write some basic code to see if I can extract that. So here's the code I came up with. We switch to graphics mode. We load in all of that sprite data starting at 6000. And assuming the width is 7 and the height is 8, and I can just tweak these until I get something that works right. My source byte will start at 60D2, and my y's will just start in the upper left corner. My y's will go from 0 up to height -1, x from 0 to width -1. That's my destination byte, so I start at the beginning of graphics, and there are 32 bytes per line, so I multiply that by my y, and then I add my x, and that should get me to the part of the screen where that byte belongs, and then I poke into the destination what I peeked out of the source, and in case I need it, I can uncomment this, which will just print those values. Then I increment the source byte So that's my command to add it to the disk. It's there. Let's run it. Alright, that didn't look like a hole, but it looks like it could be a hole. It looks like maybe if I cut my width in half and multiplied the height by 2. So we want it to be 56. So I could do 4 by 14. So a smaller width. So make this 4 by 14. That's a hole. All right. 4 by 14. Now I should double check that the hole replacement is also going to be 56 bytes. So that's going to be hex 142 minus hex 10A, which is 56. That's good. So surely that will also be 4 by 14. So I'm just going to change the source byte to start reading at 10A. So that's going to be line 30. 10A. Huh, that didn't look right. That looks like that might be part of the enemy. 10A starts here, but we have to add 1, 2, 3, 4, 5 for the preamble. This includes a lot of 2A's. And it also includes this text. This can't be right. Maybe I never did this. Maybe I never wrote any code to create the hole replacement and put it in here. So I guess I have to add that to my to-do list. And let's run that code that'll draw the alien and then poke that into the memory. Huh, looks like that did draw both of them. Interesting. Let's see if we can make that easier to see. So this is where it looks like we finished drawing the first version. So if I add a 265, if in key is nothing, then 265. And then before we start printing the bytes, looks like that's 580. Oh, I think, what happens if I get rid of 560? That's my first frame. I see, so that's like flitting it back and forth. So you can kind of see these stripes change colors and the arms flip back and forth. Because I used a get and a put to capture them. Okay. Alright. That counts as an animated sprite, folks. And let's try the other enemy that I never got around to incorporating into the game. Okay. My guess is that I was gonna like alternate the eye colors and alternate these little feet color. I don't know if that made it into the data file. I was looking at it. It would start at 179 plus 5 for the preamble, which would be starting here. I don't know, do these look like graphic bytes? They kind of do, because this promises the first version would go from 79 to 90. And if you had 5 for the preamble, that would be up to here. And then it would go 91 to A8, so 91 plus the preamble would start here. And then it would go to A8, which is here, add 5. 1, 2, 3, 4, 5. Yes, so it would end here, and then we would have the postamble at the end. So that might be it, but I have an idea what it looks like from that basic program. But you know what drives me crazy? I got 2 moon pictures here, but I only have one basic program to draw one of them. I don't know where the basic program would be to draw this one, but I can load it up and look at it. go, instead of mountains, we get these things. My artistic skills would never have told me to know to do like this kind of shading on this side, but that's what the real Moon Patrol does. So I don't know how I would have remembered that unless maybe I had a picture in a magazine that I was going by. It's not like there was internet around for me to grab pictures of this stuff, so maybe I had a picture handy, I don't know. Well, next time we're gonna try running some code and see if we can get this background to scroll.